Welcome to Syntax. On this Monday Hasty Treat, we're going to be hitting you with part 3 of 3 in our series on promises. We're going to be talking about some new stuff like with resolvers. We're going to be talking about, practical stuff with fetch. We're going to be talking about flow control, concurrency, throttling, queues, all of those types of things. Basically, we got the basics, we got the intermediate kind of syntax stuff. Now, here's what we want. We want to learn how to get even deeper with this. And if you're getting deeper into any type of new topic or code, you're going to make mistakes, you're going to cause bugs. Potentially, you're going to end up with some performance issues as well. And to track all of that stuff and make sure that you have a handle on it, you're going to want to use Sentry at sentry.io. That's sentry.io/syntax. Sign up and get 2 months for free. And seriously, just give it a rip, because once you get used to those dashboards in your project, in your application, it's really hard to live without that visibility and to just kind of be flying blind on what your users are actually hitting in your site. So let's get on into it. I have deferred the starting of this episode long enough. We're going to be talking about the first thing, deferred promises, in talking about with resolvers, which is newly available. So, Wes, do you want to? I've not used with resolvers. I'm super interested in what this is and how to use it.
Yeah. So previously, if you wanted to access a promise and its resolve and reject methods outside of the promise body, what you've had to do is you had to create a variable outside of the scope of that promise. And then when you get inside of it, you have to update the variable that's outside. That works really well. And that whole pattern is called a deferred. And that's something we've had since jQuery had deferreds for a while. It still does. And it's not a new concept in programming, but it's not something we've had in JavaScript. And there's lots of libraries out there that were just made for simply making a deferred. And let's talk about like why might you want that? I've talked about this on the podcast before, is if you want to, instead of having to pass your work into a promise, so often when you're doing a bunch of stuff, what you'll do is you'll make a function, you'll return a new promise, and then all of the work needs to happen inside of that. And sometimes it makes a little bit more sense to, instead of passing your work into the promise, you want to pass the promise itself along with its controls, its resolve and reject methods. You want to return that from a function so that you can wire it up to buttons. You may want to pass it to a success callback of another API. And promise that with resolvers will do that for you. It sort of surfaces the resolve and reject methods alongside the actual promise. Where this is really useful is in streams. If you want to be able to, with streams, the way that it works is that you get a stream, you listen for what's called chunks. I know, Scott, you're working with the webcam API right now to stream in video chunks. Is that what it is?
Yeah, and I'm sending them over HTTP to a Rust process, which is then collecting them all in a temp file, and then once the process is over, writing that temp file to a video file with FFmpeg. So yeah, currently doing that.
That's really cool, because in the browser with Media Recorder, the way that it works is that you create a media recorder, you listen for chunks, which is basically every, I don't know, you can say how many seconds, but imagine it was 3 seconds of video. You get a chunk every 3 seconds. And then the way that it works is you put those chunks into an array, and then you wait for it to be finished. And then when it's finished, you take all those chunks and you put them together and you get a video file at the other end, right?
Yeah.
That streaming API is based on events. It's like on data, right? And when you work with streaming APIs, it's not a promise, it's chunks. But if you just care about the output result, you can use the promise with resolvers to, you can say like on error and on cancel of the media recorder is equal to reject. And then on finished, you give it the resolve method, and you can pass the chunks to that. So it's not something we could never do before. It was very easy before. It was just like one more level of indentation inside of a promise, but that's one less nested promise, one less weird scoping issue that we need with this sort of helper method.
Yeah, and it's actually funny, Wes, that you say that because I've used libraries to collect a stream before as a promise, like collect stream to promise, because when working with Braintree, every single one of their search APIs returns a stream rather than you can't just async await. You can't just wait for the
Really?
data to come in. And it's obnoxious as hell when you're doing like, oh, let me just do a quick HTTP call and I don't want to have to return a stream back to the UI. I just want to collect the data and send it to the UI when it's done. Yeah.
That's actually, I've been wanting to make this for a while, is like some sort of like custom class that extends the promise and it gives you both the stream events and you can await it.
Yes.
Because sometimes I care about both. I want the output, but I also want to listen for the actual end. Like a ChatGPT would be a good example, right? I care about the end text that I get from ChatGPT, but I also want to display the text as it's being streamed in from the server. So I kind of want both. So I'm sure somebody has already built that. It wouldn't be too tricky. Let's talk about fetch. We've talked about fetch before. Fetch, you pass it a URL, it returns a promise. The kind of interesting thing here is that the first promise of a fetch is responds as soon as the server comes back with its headers. So the way that a web request works is that it requests something from a server, and the server is going to come back to you immediately with some information. It might not be all of the information, but you do get the initial headers back. And in that, you can check for the header response code. You can return. Most commonly, we all are doing .json, right? And people have often wondered, like, why is fetch two promises? The first one, and then you immediately from that, you return response.json, and then you have access to the actual data. And that's because that's the way servers work. You get the initial headers first, and then if you want all the whole payload of the body of the response, you have to sometimes wait a little bit longer for all of that to sort of come in. So most likely you're checking for a response code, you're getting .text or JSON, but you are also, we did a whole episode on streams. You may be streaming in the result or using server sent events from the server. Whereas like ChatGPT, a lot of these things are, as they are generating the actual output, they are streaming it to the browser. So I used to think like, while you're using ChatGPT, they're just doing this like fake typing to make it feel real. Mm-hmm. And the actual answer to that is that's actually not true. It's literally coming up with the result and firing it out the door before it even knows that it is done. And I've been, sorry, go ahead.
No, and it's one of the reasons why ChatGPT isn't great at commenting code if it's also creating the code. If you tell it to create code and comment the code, it always puts the comments below the code it just wrote, because unless it's writing the comments first, maybe you could tell it to do that. It's kind of like coming up with what it's trying to do as it's doing it.
Yeah. I don't even know when I'm going to be done, but here's what I've got so far. And I've noticed I use Raycast. They just rolled out Claude Haiku support. And I noticed using the Claude one, sometimes it's like 8 or 10 words into the response, and then it just clears it and puts something different in. And it must be because as it's coming up with the result and as it's imagining more of the sentence, it goes, you know what? Those first 8 words I said could be a bit better, and it replaces it. So I thought that was kind of interesting with streaming. Flow control. How do you flow through promises? First of all, looping over promises. You can use a for of loop, and you can await inside of a for loop. This makes everything synchronous, meaning or series is often a good word for that, because the word synchronous in JavaScript often means that it's blocking. But in our case, you simply are just like pausing the for loop as you're doing it. And that is a good use case if you want to do one thing after another. Like we talked about me downloading 10,000 files a couple episodes ago. I initially had wrote a for loop, and that was kind of slow because you download one file, you wait for it to finish, then you do the next one, then you do the next one. In reality, there's probably some sort of use case in between doing them in series, which is one after another, and doing them all at once with promise.allSettled, which is 10,000 at once. There's some sort of middle ground, and we'll talk about that in just a second.
Yeah, I can think of like some APIs too. They return things in pages. So you could say, hey, go off and fetch page 1. All right, page 2 has come back. Sometimes what they do is they give you like a key for what the page is. So then you pass that into the next fetch call. And then you like the data that precedes it matters for the data that you're trying to get next. So that would be a good reason to do a for loop.
Yeah, that's a great use case, because sometimes the API will tell you how many pages there are, and you can fetch them all at once. But often, they don't know. You just keep going until there's no more. And often, the only way for you to tell that is the next time you fetch one, the result is empty. And then you're like, oh, well, there's nothing here. I must have reached the end of the road, and I no longer have to keep doing that.
Bored.
And also in cursors, that's something we haven't talked about a lot as well, is sometimes APIs are not based on pages, they're based on cursors, meaning that in order to get the items after the ones, you need like a cursor ID, and you can't do it until you have the cursor from the page before it. You can't use like a map. If you have an array of like names and you want to fetch, like you have Scott, Wes, and CJ, and you want to go to the GitHub API and fetch all 3 of our profiles, often what people will do is you'll map over each of those strings and return a promise, like return a fetch request that goes to those 3 URLs. And then you'll wrap that in a promise.allSettled to get all 3 of them. Those run concurrently, meaning they run at the same time. It's not technically, we have a whole show on that, but you can think of it as that. A while loop, again, a while loop is not something I reach for all the time, probably a couple times a year, but you can await inside of a while loop, which can be useful if you want to just wait for the next item to come through.
While loops. Yeah, I don't find myself using while loops that often, but the other day one did come up and I while looped it, that's for sure.
Concurrency, throttling, queuing. So I find myself getting into this area a lot where I need to make a whole bunch. It's almost always with fetch. I need to download a whole bunch of files. I need to hit an API a bunch of times to get all of this data. And you find yourself into the situation where it is way too slow to do them in series, one after another, but it is not possible to run them all at once, because that will, like, your internet provider will probably shut you down, or you'll hit some sort of like DDoS thing. If you send 10,000 requests to download files to an API, you're probably going to get in trouble. So there are some really nice packages out there, specifically pmap, plimit. Sindre Sorhas has, I don't know, probably 15 different p-dashed things. And they're all like little utility libraries. Quite honestly, I forget which one I need every single time, and I have to read the docs. But like something like pmap will allow you to create an array of possible promises. So loop over this list of 10,000 files and return a function that will download a file once it has been triggered. And you give all of those to pmap and you say, run 5 at a time at most. And what it will do is it will simply it'll fire off 5. And then as the first one finishes, it goes down to 4 and it starts the next one, and then it starts the next one. That's better than chunking, because chunking will do like 5 at a time, wait for them all to finish.
And then another 5.
Wait for them all to finish.
Yeah.
Whereas like concurrent mapping will always be running 5 and always tearing off a new one as soon as there's a single spot.
Yeah. Huh. Nice.
Yeah, it's pretty handy. I used to use this thing called async.js for callback-based architecture, but I don't use it all the time. And I don't use it anymore because between promises, promise all settled, and these little helper functions, I find them to be more than enough. There's also like plimit, pthrottle, pdebounce. These will allow you to only run them after a certain amount of time, or at most every 2 minutes. So often you will only be allowed to create 60 requests per hour. So you want to say, or 60 requests per minute. So you're like, okay, well, don't run more than 60 in this time span, or don't run this function or run it at most once every 1 minute, and that kind of stuff can be really, really funky. Or retrying is another one. There's libraries out there for run this promise, and if it fails, retry it up to 6 times, and if so, then finally reject. And having that all built in is really, really nice.
Yeah, I have not. I mean, it's funny. I have used throttling and debouncing, but I haven't used any of these P tools before. They're
It's
all pretty
always
neat.
scraping for me. It's funny. So maybe that's where you'll have to hit it. Or like the OpenAI API only allows you to run it a certain amount per minute.
Okay.
And sometimes these APIs will return to you how many calls you have left and when your call amount refreshes. And if that's the case, I'll just look at the header and say, all right, if I'm out of calls, throw a 500 milliseconds wait in there, and then fire it off. But if that's not the case, they don't tell you how many you're allowed. They only tell you if you can't run it. If that's the case, then you have to use one of these libraries and put in the hard limits so that it won't run it too frequently. TypeScript and promises. This is the last thing we have here is just how to use promises in TypeScript, right? Because promises are a generic in TypeScript. It's built in, and you'll often see that in TypeScript. It's promise, angle brackets, and then the actual type of the value that you want. And if you fetch something with a specific type, you'll see it's promise, square bracket, whatever. And if you put in a wait in front of it, it will unwrap the promise and actually give you the real type.
Yeah. And so to be clear, the reason why you do that promise with the brackets around it, that is essentially saying, hey, this thing does return a promise, but then the promise itself will return that type.
Exactly. It'll eventually resolve to that amount. And a couple times I've needed to get the type from a function that returns a promise. And if that's the case, like you're using like a type of a specific function, sometimes you want to take the promise off. Like you want to unwrap it. Like this function returns a promise that is of a user. But you're like, I don't care about the promise part. I want the type of user. And if that's the case, you can wrap it in the awaited TypeScript helper, and that will take the promise part off and give you the actual type there. Promise.allSettled filtering. This is just like a TypeScript thing in general, and I bet this will be fixed soon, but I've also been saying this for a while. If you have an array in TypeScript and you try to filter it, by default, if you don't use any like patching libraries or anything like this, the filter does not actually narrow the types for the items that you filtered it in, which is annoying. So you have to add a type guard to your filter to actually tell TypeScript, no, I'm filtering it down. And I run into that a lot with promise.allSettled because it will return, again, the fulfilled and the rejected values. And if you want to just filter for the rejected to display some errors, and you want to filter for the successes to display the data, then you'll have to write a quick little type guard. And I think there's a type called promise all settled result. And then you can write a type guard that will check for either the reason or the status property on there. And lastly, there's no way to type the rejected value of a promise. And that's a little bit of a pain as well. It can be nice to use that. In the last episode, we talked about that writing like a wrapper function that will do collecting and give you a tuple, error first, data second. You can extend that a little bit further and internally do a type assertion. And you can say, all right, well, if it does return an error, you can use a generic to say, this is what the error will look like. And that is really nice because now you're not doing the whole, like, if error is an instance of error or if error has a message property, and you just know exactly what the error type is.
Wild.
Yes, I think that's it for promises. Wild world. I'm impressed that we were able to get 3 episodes out of this, but there's a lot of funky stuff to learn about promises, and it's good to know.
Can you imagine if we would have had to do this episode on promise libraries before promises existed? Yeah. It
would have been, there's so much, like with the promise libraries back in the day, you had to wrap everything. Even in Node.js before like like the file system APIs didn't have promise versions of it. You had to like wrap their callback based APIs in a like util.promisify.
I did not get it. Yeah, actually got to wait until promises landed in the browser before I had to deal with promises. I just used callbacks until then. I was like, you know what? This doesn't seem worth it to me.
That too.
Yeah.
Awesome. All right. Well, thanks everybody for tuning in. Tweet us your promise tips at SyntaxFM. Would love to hear them.
Sick.
Peace.
Peace.